Okay, so here we shall explain the concept of the mean value theorems and some examples on their applications. So the first theorem is the Rolle's theorem. So the Rolle's theorem states that let f is a function which maps from a to b to r. R is a set of all real numbers. So let f be a continuous function. Let f be continuous. Let f be continuous on the interval, on the closed interval a to b, and it is differentiable. And it is differentiable on the open interval a to b, such that the value of the function at a is equal to the value of the function at b. Means at x equal to a, the value of the function, and at x equal to b, the value of the function is the same, where a and b are some real numbers, where a comma b belongs to R. Then there exists some c which belongs to the open interval a to b, such that f dash c that is equal to 0. So we can understand by this Rolle's theorem graphically. So if this is the x-axis, this is the y-axis, and suppose if we have a function like this, this is the function f of x, suppose y equal to f of x, which is the graph of y equal to f of x. So here, suppose at x equal to a and at x equal to b, the value of the function is the same, suppose. It means that this is x equal to a, this is x equal to b, and at x equal to a and x equal to b, the value of the function is the same, which is f of a equal to f of b, this value. Then there exists some value c in between a to b, at which the slope is 0. It means that the slope of the tangent to the curve at x equal to c will be 0. So therefore f dash c that is equal to 0. Since why? The slope of the tangent at x equal to c is 0. It means that the tangent should be parallel to the x-axis. It means the tangent is parallel to the x-axis. So this is the Rolle's theorem. So here we have seen that, here we can see that there is only one such point C in which the slope of the tangent to the function is 0, but there can be more than one such point. Like, for example, a function is, suppose, say like this. So here also we can see that the value of the function at x equal to a, that is equal to the value of the function at x equal to b. So here also the slope is 0, and at this point also the slope is 0. So here also the slope is 0, here also the slope is 0. So here at these 2 points, say at x equal to c and c1 and c2, suppose this we can tell c2. So at x equal to c1 and at x equal to c2, the slope of the tangent is 0. Slope of the tangent is 0. It means that f dash c1 that is equal to f dash c2 that is equal to 0, where c1 and c2 belongs to the open interval a to b, and here f of a that is equal to f of b. This is f of a that is equal to f of b. So at only, we can also have only one point in between a and b such at which the slope of the tangent is 0, or we can have two or more than two such points in between a and b where the slope of the function is 0. So provided that the function should be continuous on the closed interval a to b. So if it is continuous on the closed interval a to b, and it should be differentiable also in the open interval a to b, only under these conditions the Rolle's theorem is applicable. So the Rolle's theorem is applicable under these two conditions, else it is not applicable. So hope you understood. Suppose we can give one example that on the Rolle's theorem. So it is asked that verify Rolle's theorem. Verify Rolle's theorem for the function y equals to x square plus 2, where a is equal to -2 and b equal to 2. So now here we can see, so now here, therefore the function f, the function y equal to x square plus 2 is continuous on the closed interval -2 to 2, and it is differentiable also, and is also differentiable in the open interval -2 to 2. Also we can see that f of -2, that is equal to f of 2, that is equal to -2 whole square plus 2, which is also equal to 2 square plus 2, which is 4 plus 2, which is 6. Now, therefore, f dash x, that is equal to 2x. Now, f dash x that is equal to 0 at x equal to 0. Which means that f dash 0 that is equal to 0. Now, 0 is a real number which belongs to the open interval -2 to 2. 0 belongs to the open interval -2 to 2, at which f dash at which the derivative of the function is 0. It means the derivative of the function is derivative of the function f of x is 0. So therefore, the Rolle's theorem is verified in this case. Therefore, the Rolle's theorem is verified. Hence, okay. So hope you have understood the Rolle's theorem. And then the next is the mean value theorem. So the mean value theorem, it states that let f be a function which maps from the closed interval a to b to r, where r is a set of all real numbers. So let f be a continuous function. Let f be a continuous function on the closed interval a to b, and it is differentiable also. And it is differentiable on the open interval a to b. Then there exists some value c which belongs to the open interval a to b, such that f dash c that is equal to f of b minus f of a by b minus a. So the mean value theorem, it is an extension of the Rolle's theorem. So it simply states that if f is a continuous and differentiable function from a to b, then the slope of the secant, which joins the points A and B, means the slope of the line segment which joins A and B is same as the slope of the tangent at some point C which lies in between A and B. So we can understand this graphically also. Suppose let's say this is a function f of x, y equal to f of x, and this is x equal to A, and this value is x equal to B, suppose. So then the line segment which joins A and B, so at this point the value of the function is f of A, and at this point the value of the function is f of B. So therefore the slope of the line AB, slope of the line segment AB, that will be equal to y2 minus y1 by x2 minus x1, obviously y2 minus y1 by x2 minus x1. So y2 at this point, the coordinate of the point B is b comma y, f of B, and the coordinate of the point A is a comma f of A. So therefore y2 minus y1, that will be f of B minus f of A by B minus A. So we can also find some point x equal to C where the slope of the tangent to the function, the slope of this tangent, slope of the tangent at x equal to C, that is given as f dash C. That is also same as the slope of AB. Since why? Since here we can see the tangent is parallel to the chord AB. Since the tangent is parallel to the chord, or we can say the secant AB. So therefore the slope of the tangent f dash C, that is f of B minus f of A by B minus A. So the same thing can happen in more than one point. If the function is say like this, then we can have two such points at which the slope of the tangent will be equal to the slope of this chord. So we can understand this mean value theorem by one example. Suppose one example is that verify the mean value theorem. Verify the mean value theorem for the function f of x equal to x square in the interval, in the closed interval 2 to 4. Now here we can see here the function f of x, which is equal to x square, is continuous. So the mean value theorem is also applicable under these two conditions. It means it should be continuous within the given closed interval a to b, and it should be differentiable also on the open interval a to b. Only then the mean value theorem is applicable. So here the function f of x equal to x square is continuous in the open interval 2 to 4, and it is differentiable in the open interval 2 to 4. As f dash x, which is equal to 2x, is defined in the open interval 2 to 4. So its derivative exists in the open interval 2 to 4. So it is differentiable also in the interval 2 to 4. So now f of 4, that is equal to 4 square, which is 16, and f of 2, which is equal to 2 square, which is equal to 4. And therefore we need to find f of 4 minus f of 2 by 4 minus 2, that will be equal to 16 minus 4 by 4 minus 2, that is equal to 12 by 2, which is 6. It means the slope should be 6. Now therefore f dash c, that should be 6. It means that 2c, f dash c means 2c should be 6, so c should be equal to 3. So it means that f dash 3, that is equal to 6. F dash 3 is 6. since it is 2 into 3, that is 6. So therefore you can see that f dash 3, that is equal to f of 4 minus f of 2 by 4 minus 2. And 3 also belongs to the open interval 4 to 2. It means, 2 to 4. It means that it lies within the given interval 2 to 4. So it means that in the given interval 2 to 4. So therefore we can see that the mean value theorem is verified for this function. Therefore the mean value theorem is verified. So hope you have understood the mean value theorem also and its application, and the Rolle's theorem and its application. So thank you.